Okay, is it working? I don't see green yet. There we go. Okay. So I can put that to the side. And, yeah. Just wait for everybody to get here and then take a peek inside of the box. See what the deal is with this thing. So, in the meantime, I'll leave the 29. People have asked me about the 29, so I'll leave that there really quick, and therefore the people who ask about the 29 can see the 29. A lot of interest in the 29. So, Loose Cannon is first, and Mike is second. Okay, so, oh, Peter, we're good. Thanks for asking. We are good. But, yeah, I think it was some of you guys that asked me about the Cobra 29. Obviously I put one in the Cobra 29, and, you know, there is kind of a problem with this whole situation with the Cobra 29, and I didn't figure it out until I already had mounted the bloody board in here, and that is that you can't put the speaker down in there because the speaker, it's right here, and this isn't low enough, so you end up with a situation where, yeah, it doesn't quite, you know, fit. So it's touching the board, and so you end up with that, you know, gap. So this has to be rotated. But other than that, yeah, fully installed in the 29. This is going to be my test radio. I just have to, you know, unbolt this and, you know, flip it around or something, you know, so that I can, you know, close the thing up. But yeah, 3-digit display is obviously in it. Good to go on that. Yeah, it's red because I have tons of red and already made, and I didn't have any green, so I just went with the red. Even though really I should have a green display in it. But yeah, it's good to go. So you can see that's pretty much its range. So anyway, so that's the 29. Not too much special there. That's what I said. I was kicking myself. I was like, damn it, you didn't measure this beforehand. You just didn't. I mean, and I went and had all these leads all dressed up, and, you know, it's all neat and clean, and yeah, I was kicking myself pretty big there. I was like, you gotta be kidding me. Why didn't I measure this first? You know, I just didn't. I knew that the 29s have the big speaker in them, you know, like the 25s do. And, you know, and I knew that. I was like, God grief, what have I done to myself? So anyway, I got this thing here. This thing here has some interesting things that caught my attention. And for you guys down under, frequency expanding, okay, A, B, C, D, E, F, Poland, and New Zealand band. That's curious. So this is not an American FCC approved radio. It's an imported radio of some kind. And I have never seen it, but looking at the size of this box, I think it's the size of a Cobra 19. Oh, and it has FM, which, yeah, would make sense, I guess, because in New Zealand, they have to have, they're FM, aren't they? Or for the most part. So we got an owner's manual. 2 user. Oh, this is good. Okay, here we go. We get some classic Chinglish here. Two, look at the Google Google thing just goes off here. I didn't say anything about, you know, hey Google or something about Google or anything about Google, but the phone decided to go off. To user, welcome to use Luiton LT-298 AM/FM CB radio. It is a high-quality CB radio which is suitable for Poland, Romania, Germany, UK, Italy, Russia bands. So yeah, we got some good Chinglish there. So connect the supplied electric condenser microphone to this connector and then lock it via the ring nut. I think they meant to say connect the supplied electric condenser microphone. But yeah. Down key. Press this key, channel number runs down. The squelch control allows to silence the receiver by cutting the background noise. Yeah, we got some good Chinglish in here. That's always fun. So we have the radio and, you know, bits of cardboard. They didn't pack it very well. So this is it. It's 115 by 35 and 150 deep, not including obviously the knobs or the connector on the back. And we've got a power cord that, you know, they didn't put a plug on it. They just put a wire with a plug in the end. Microphone is really, 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 really small. Yeah, really, really, really small. Oh. Fag lighter, anyone? Curious that it comes with this. Okay. And a bracket and knobs and, you know, hardware and, you know, all that sort of interesting stuff that doesn't mean anything. Now we get to make fun of it. Unless it works really good, then I'll be pleasantly surprised. But I don't want to turn. Do I want to turn it on first, or do I want to? The hell with it. We're going to take it apart. I don't want to turn it on. I want to take it apart. I want to Dave Jones it. I was watching Dave Jones using an AVR ISP, and it was painful because a guy as smart as Dave, he could not figure out how to use a programmer that you simply plug into a computer and hit flash in the damn Atmel Studio and be done with it. I could not watch that one anymore. It was too painful. It's like, Dave, you're doing it all wrong. It's like I started talking to the screen and I said, I can't watch Dave do this anymore. It's just too much for me. It's the most simplest device in the world. Plug it in, it works. Okay, so there's really nothing on the bottom. I mean, nothing. There's no nothing on the bottom here. Oh, yeah. Ooh, look at the really thin wires. Really thin wires. But I guess you don't need much for a 3-watt speaker. Okay, so what have we got here? That looks like a reed switch or something. So I don't know what's up with that. I also noticed that the final is encased in a can. The driver is mounted to the side, and the final is encased inside of a soldered shut can that's soldered to the back. That's rather interesting. So we have 5 transformers, I don't have any bannerizers. It looks like a reed switch to me. I would say that it... No. Yeah, I'd say that's probably a reed switch, yes. This guy right here, I think it's a reed switch. It's a B-Star BR700. You can just whack that into the Google monster. And I think that's a reed switch. It looks like a reed switch to me. I don't know who B-Star is, but that is a form factor for a reed switch. It's a reed relay. I'm sorry, not a reed switch, a reed relay. Roger beep, I do not know. It does not have anything here to indicate that it would have a Roger beep in it. It just has a on-off volume. It is a reed relay. That is a very bizarre thing to have in this radio. I mean, that is by far one of the more bizarre things I've found in a modern radio, is a reed relay. That's pretty strange in itself. I can't say that I've actually ever seen that before. That's very bizarre. I don't know what they could possibly be doing with it, but anyway, so these other components that we have. We have a UTC 3361E, which I believe is probably an IF. That number seems to ring a bell. We have a MCD 2926, which I'm almost positive that that is a PLL chip. I think that's a PLL. Yeah, I think that that's a PLL. Yeah, the new Cobra does have two relays, but and you know what? They're not. These reed relays are not exactly cheap, which is why I'm surprised that they used it. MCD 2926. MCD 29. Come on. 2926. I'm pretty sure that's a PLL chip. 2 dual modulus prescalers, 3 programmable counters, 1 crystal oscillator, 2 phase detector, and 2 programmable charge pumps. I'd say that's a PLL. I have heard of them. Someone I think asked me about it. So, and of course we have a Fujitsu MB95F354, which it's anyone's guess as to what it is, but I'm thinking it's a microcontroller. I'm just not up on my Fujitsu microcontrollers. So MB, what did I say it was? 95F. 95 Frank. 354 Edward. 354 E. Supported by LNIC device, really? Oh yeah, it's LNIC devices. Support by programmers. ISP connector. Cypress. So we got a data sheet for it here. It's a Cypress 8-bit microcontroller. It has the following hardware. It has main oscillator clock to 16.25 megahertz, external clock to 32.5 megahertz, a collectible sub clock, so it's basically got some PLLs and stuff in it. Timers, it has 8 16-bit composite timers, so it probably has one 16-bit timer or 2 8-bit timers, a time-based timer, a watch prescaler, so it probably has a real-time clock in it. One UART, so it can be either a UART or an I2C channel. Built-in wake-up functions, standby mode or fast mode for I2C, fast mode being 400 kilohertz bus rate. 6-channel external interrupts. It has an 8 or 10-bit A to D converter. So either 8-bit or 10-bit resolution. That's going to be, if they're using the A to D converter, they're going to be using it for the S meter on here. Has a hardware watchdog, low voltage detection, reset and interrupt, clock supervisor, dual operation flash. How much flash does it have? Did I miss that part as far as how big the flash is? I'm fairly certain that it doesn't say here. Okay, here we go. Here's the product lineup. So our variant here is the 354E. So the 354E has 20 kilobyte of ROM and 496 bytes of RAM. Whoa, wee, that's small. Woohoo! Let's see, 136 instructions, 8-bit instruction length. So, yeah, it's not the, the fastest thing in the world. So, how many erase write cycle on the flash is 100,000 write erase and a data retention of 20 years. So it's basically, that's in line with like an AVR. Anyway, so that's obviously our processor. We have a display driver up here. I'm not sure how easy it is going to be to get. Actually, it's not going to be easy at all to get the face off, because I've got screws going through the circuit board into the face, and they got these board edge connectors that are just the solder blobs in the corner, board-to-board soldering, and it looks like they have 2 different kinds of displays that they would have put in this radio, because we've got a connector here, or a part or a pad for a connector, so that's probably for a different kind of a display. So the display is probably used in a different radio. The encoder, or sorry, not encoder, volume on off, is the only apparently decently sized hardware control in the radio. So anyways, VCO is certainly going to be underneath the can. Anyway, I'm going to turn it on now. We're going to see how interesting this particular monstrosity is. I have no idea about channel mods, but presumably it's probably modified out of the box. I mean, it doesn't have any certification statements for any country on it. So I'm willing to bet that it's just out of the box. Okay, so my power supply current was turned down. So the channel selector is an up and down button on here. Yeah. Let's see. Oh, so it has an RF gain and a squelch. We have a channel 9 and 19 switch. We have AM and FM. Oh, I see what's going on. So when we go to FM and we go to AM, it says CE on the display. So that's going to be EU band plan, I would imagine. We go to FM, it says U. I don't know. I don't know what frequency or band plan we've got in this thing. So we're going to have to plug it in and just key the radio up, see what channels or whatnot these things are on. Yeah, but in a radio like this, I don't think there should be any issue. Okay, so transmit 2 watts. Oh, this thing is on bloody UK band right now because it's on 27.60125. Yeah, so this is on, and that should be 27.9912, yeah. So when we're on FM, we're on UK. When we're on AM, this has to be 26.965. So is that 27.405? It is. So what about 23? Because I'm pretty sure that they don't have the jumps. 23 is 27.25. Now correct me if I'm wrong, but I didn't think that the European band plan had the jumps around channel 23. I thought that channel 23 in Europe is 27.235. I thought that was what it was. But this is clearly FCC. So, but how do you get it to change bands? We got channel buttons on this. We got AQ. The AQ, I think, is a squelch. Like an automatic squelch or something like that. It has an external speaker jack on it. I was beginning to wonder. Oh, yeah. Oh, it's on FM. Or no. It's just noisy. My God, that was AM. So the radio puts out 2 watts. Which is rather curious. I mean, 2 old friggin' watts, you know? Okay. LT-298. It probably needs a mod. But I can't imagine it needing a mod because it... Let's see. That's the PLL. We got a couple of jumper spots in here. We could measure them and then try to pull some of these things up or down with some resistors to see what these pads do. 3.7 volts. And this has got 1 on it. That's a ground. Or at least I think it is. Well, that's ground. Certainly, it says it's got bands. Or so it says. There's probably a way to change them. Do you hold the button? No, because holding the button just changes the channels. Yeah, same with that button. It's supposed to have bands, so... not seeing how you would change them. When you change from AM to FM, you get the U and you get the CE, and that doesn't, nothing else seems to change it. So, yeah, I don't know. Maybe you turn it on and... No. No. It just comes on and says CE, you know, Central European, or whatever the CE means, and you know, I know that's just the EU band. So it has EU band CB, which is the same, clearly running there. It's FCC, and it has UK as well. So, I mean, it's kind of like it's a stock right now, a stock radio from like the UK or something, because it has the European band and it has the UK band on FM. So this doesn't have any Ofcom or any kind of label on it. So it doesn't have any certifications to any regulatory body that in the world. So Bond Telecom. Like, we don't have any FCC, we don't have any Ofcom, we don't have anything. Nothing. ROHS and the, don't throw me in the garbage bin label, and the, CE and all that wonderful stuff, but the 6-page manual, I don't know. So, I don't know how to modify it. If it can, I mean, it says on the box, bands, all these bands. Frequency expanding. The New Zealand band is down below channel 1, down in 26 megahertz. So it clearly must have a way to expand. But how? Where does it expand? Tell me your secrets, oh radio. We got a little tiny little filter there. Because, it does have an FM receiver in it, so. And an FM transmitter. So. Oh, tell me your secrets. It has a 10.25 megahertz crystal in it. That's interesting. Well, I don't honestly know. Unless somebody has a clue. Yeah. Frogs? I don't hear any frogs. They don't come out until the summer. And then the tree frogs are out so loud you can't hear. No, I don't think you can do New Zealand. I mean, it says, New Zealand on it. But, I hear my little guy. He's upset. Wonder why he's upset. So, probably bedtime. Actually, yeah, it is about bedtime. Yeah, I don't know. Well, the problem is that it certainly has a microcontroller controlled PLL chip. I would be willing to bet that it can do it, and it's a matter of figuring out how to trick this guy into it. If the software does it. Because certainly it could do it. I don't know how well it would broadband. But then again, I was surprised by a Cherokee. I had a Cherokee that goes from like 26 to 20, like 23 to 30 megahertz. It's nuts. That's that CM10, that Cherokee. I didn't see Peter's video. What's Peter's video about? Somebody has to tell me where I can go see Peter's video. Alright. So, is this rubbish or not? Jeez, man. He's not happy. Yeah, he's unhappy. I think Mom is giving him a hard time. So, let's see. Where's my lens? There it goes. Oh. And then I guess he wasn't talking about you. He's talking about a different Peter. There's a lot of caps in this radio, though. Oh, wow. Oh. Yeah, Buddy did. Oh, yeah, I haven't watched it. Not yet. Okay, so we have caps and resistors around the microcontroller. We don't, it's not like we have a whole lot of pins here, you know? I have the data sheet for the micro. So we could be able to deduce we should be able to deduce from the pinout of the chip which pins are more likely to have a something that would change the program. So if we look at the pinout, and what we need to do is we need to probe around this with a scope. Hello, Santos. I actually did that. I turned on the radio with various combinations of buttons. There's not very many buttons. You know, like those two down, and it didn't do anything. Oh, wait a minute. I tell a lie. That did do something. I totally tell a lie. What did that do? One, two, three, four, and 5. That's curiously like a band selection kind of thing. Okay, so now how do I confirm it? Bolt again? Do I hold them in? Do I change it and then turn? No. Okay, so what did that do? Helps to have an antenna. No, it's a imported from Europe radio. 26965. Okay, so when I turned it on, I held in up and down and turned it on. It says CE, and then I can only go from channels 5 through 1. And it doesn't transmit. On any of the channels. I don't know. It doesn't go out of this mode. And pushing both of the buttons in doesn't do anything. Yeah, and I think that probably is the band. I have a feeling that that is the band. But how do you confirm that I want that band? I don't know. Well, wait a minute. Did that do it? No. Uh-oh. It went off. Oh, it's my connection here isn't the best in the world. All right, the buttons, turned it on. Say select band 5, I turn it off. It comes back on. It's on 5, but that's channel 5, you know? And on FM, that's 601. That's, yeah, I've got it plugged into a counter. FM band is UK, AM is European. It's just that I think that we're onto something there with that, because you turn it, you push both buttons in, you turn it on, and now it'll only go between 1 and 5. So that clearly has to be some kind of band selection, you know? And, you know, 26615 to 28305 would be, what would that be? That would be 5 bands. 5 bands of 40, wouldn't that? So that actually lines up. But how do I confirm the band? Hold in buttons again. That just scrolls it through. It just scrolls the button. Yeah, so how do we confirm this? That we want this? You know, what's the magic sauce here? How do I confirm it? I've already done that. I turn it to 3, for example, and turn it off. I turn it back on, and we're back on 3. But we're back on, you know, being able to change it. That's channel 40. Yeah, I don't know. It's like it can do it, but there's another button that would normally have been on this particular setup or something that maybe would have done it. I don't know. I really don't know. There's something to that though, but you know, what is it, you know, kind of, it's a what is it thing, you know. So if I go back to looking at the chip, you know, like what GPIOs on this chip could possibly be 4 buttons and stuff like that. So is this a grounded radio? Yeah, this is a common chassis ground thing. I think most new radios are just that way. All right, 10.24 crystal. Let's turn it on. Let's see if we got that. We do. Oh, sorry, 10.25. Yeah, so we got that. So this XOX1 on here should be some kind of clock input, which it is not at all. But that could be using an internal clock, which would not necessarily. These are not connected to anything. Pin 1 and 2. Pin 3 is a VSS or a ground. That it clearly is. Pin 4 is X1A. So what we want to do is we want to change things when we got pin 4 going. If I can keep the thing on pin 4. Alright, so we got pulses. That's like data pulses. Yeah. Come on. It's probably I squared C data pulses. No, that couldn't be. Well, hang on. I tell a lie. Nope, that's I squared C. Yeah, they're negative pulse. Active high, yeah. I squared C. Okay. We'll have to probe that one to see what's going on. But that looks like the clock. So this one's probably the data. Yeah, that's data. Okay. So that one's data. Where are we at? We got 6 is a VCC, 7. 1, 2, 3, 4, 5, 6, 7 is a nothing. Doesn't do anything. Nope. Not when you transmit. Just nothing. Alright, how about modes? AM or channel 19? Nope. Yeah, nope. So that doesn't do anything. This is a reset or an I/O. Looking at the components around it as a pull up or a pull down and a capacitor, it is a reset. Yeah. Do you know anything about it? The Luiton. It's supposed to have a New Zealand band. Here, look at the bottom line of this box. Or the whole box. That's what it is. So, the bottom line, frequency expanding, A, B, C, D, E, F, Poland and New Zealand. We could get it. I could get it into where we change the bands. I have a sneaking suspicion that that is the changing of the bands. But here's the deal. Okay, let's just get rid of the microphone. Okay, so you got 12, you know. AM is FCC or European. FM is UK. Okay, so when I go to FM, that's UK. That's European or FCC. So, yeah, that's what I'm trying to figure out. Now, if I turn off the radio and I hold the channel buttons down and I turn it on, I can only go through 5, but I can't figure out how to confirm that I want this band. Like, there's no buttons that I can push on the microphone in any combination that I can find to say, okay, I want this band, if this in fact is a band, because I suspect that it is a band. But what what band, how do I say, okay, I want that one? Because if I change the buttons on the microphone, it does the same thing. It just goes up and down. Now this is like some kind of automatic squelch or something in the microphone. I can actually change that and it's irrelevant in this mode. Like, you see how when I would turn it on before and it would say, it... Is that a video on changing the bands? I don't think I can type that into my phone. How would I get that up on my phone? What should I search for on YouTube to get to that? Oh, the Thunderpole T. Is it the same as this? I mean, if it's the same, okay. Thunderpole T800. It does look very similar now, doesn't it? I mean, that's like identical to yeah, I'd say that's probably it. Changing bands on a Thunderpole T1000. How do you do it on the T1000? Maybe it's similar.
Okay, this is how to change bands on a Thunderbolt T1000. Start the radio turned off.
Okay.
Up the channel button. Or turn it on. Let go of button.
Okay.
Use the channel selectors to find which
Only one button. On that one, he did channel up. Channel up. Turn it on. I got the same U. Now he had the U too. Okay, so I need to probably watch the rest of the video, because he had a U and I got a U just like that. T800 conversion. Let's take a peek. Changing bands on a Thunderbolt T800 CB radio. Thunderpole TV. It's only a minute long, so bear with me here while I take a peek. Turn off, push PTT, and down button on the microphone. That's what he just was getting ready to say in the video. You beat him to it. PTT and down. Turn on. It just goes right to transmitting and goes to 40. That didn't really work. Wait a second. PTT and down button on mic. It just goes to transmitting. It doesn't work the same on this one, clearly. Yeah, it just goes straight to transmitting. There's probably a little bit more to this.
Turn on the power using the volume control. Use the up and down buttons to select band.
Okay. Well, you see, that's the thing. They get the U, and I guess they release it. I don't know what's wrong with that little guy in there. Okay, so I didn't get the U this time, though. No, it just goes straight to transmit. I get the U when I go to the channel up button on this one. I'm going to have to go see what the hell's going on. Yeah, it doesn't work on this one. No, I'm going to have to go figure out what the hell's going on. Okay, so how did I get that before? I was getting the U. Right, but I get that. It always says that when I turn it on. It depends on where the switch is. Like if I put the switch in FM, it says U. Oh, because that's how it... Yeah, it was in FM. That's why I was getting the U before. It just does that by default on this. It doesn't work. Hang on a second, guys. Let me go see what the hell's going on with him. Just bear with me a minute. She's trying to put him to sleep and he's being obstinate. That's the problem. No, the channel, it's in the middle. Yeah, if I push the down button and turn on the radio, okay, if it's in FM, I'll get a U. How do I do this? Okay, because it always does that. See, I don't hold anything on the radio, and I'll get a U. It doesn't matter. Right, but I'm holding those down, okay, right now, and I turn it on. It immediately goes to transmit. You see? It just... So it just doesn't do what his video does. It just doesn't do it. It immediately goes into transmit. So, you know, right off the bat, just straight into transmit. So it, same thing, but there must be something else done first. You know, there's something being done to the radio first. Something's getting changed in here, modified. Yeah, it's not... That's what I was tracking down. You know, what GPIO on this microcontroller. That is putting the radio in channel and turning it, pushing both buttons down and turning it on. And then I just get this 1 through 5. But I can't do anything from here. Like, it doesn't do anything. So if I hold a button down, yeah, see, it doesn't. Yeah. Because PTT may have something to do with it. So if I PTT it, push those two down and turn it on. But I can't, like, there's no way to confirm this. Wait a minute. Nope. That's because it's in bloody a UK band. All right. Radio is off. All right. So I'm just watching the chat. So you guys got the radio. I got it off. And then I'm guessing, like Peter, what you're saying is PTT. Hold both of the buttons down because that's where I get the band selection. Hold those down, turning it on, releasing the microphone. So if I go to 4 there and turn it off, it's still on 4, but that's CB channel 4, you know? Okay. Which button? There's 3 of them. I could try both buttons, but I have a feeling that electrically the up and down buttons are the same as the up and down buttons on here. They're holding the button down, turning it on, and it doesn't do anything. Button on, key down, it immediately goes to transmit. Yeah, it doesn't do what theirs do in their videos. Let's see. Thunder. Let's see if I can find it. Pole T. What is it? 800. So if I look for Thunder Pole T800 mods, the T800 is an all-new UK radio with multi-norm capability. The radio has ASQ, which is what this thing here is. I did watch the T800 video. It doesn't do the same thing. Yeah, it doesn't do the same thing. The T800 video does something completely different than this radio is doing. Yeah, I don't know. I don't know how to change the bands. Presumably, there's got to be a jumper. When it's in UK mode, it transmits to 27601, 611, so on and so forth. You know, it's UK band when it's on FM. When it's on AM, it's American CB or EU, FCC band. So, on eBay, the Thunderpole T800 is a UK EU AM FM radio. So when it's on FM, yes, 60125, yes, it's UK band. So on FM, and you see it changes to U, channel 1. Oh, did I turn it off? Oh, my power cord is fickle. 27601203. It's a little out. I mean, you know, it's okay. And now 40 is 27991221. That's FM. When I flip it onto AM, I get a CE, you know, for European. Also, you know, FCC. And channel 1 is 26964927. Close enough. But I don't know how to get it to change bands. This one may not be capable of changing bands. It could be just different microcontroller code. That's entirely possible. Same radio, different microcontroller software. Or it could simply be configured by some kind of jumper or the like. Anywho, so the jumper is what I was trying to discover. Yeah, I'd have to ask the eBay guy, say, hey, if it's sold as being changeable, how do you do it? Unless they're told that it's changeable and they believe it's changeable, but it really isn't changeable. Yeah, see, that pad can't possibly jump to do something. Yeah, I don't know. I'm going to go with right now that it isn't changeable. Because there's no telling you know, how you do it. Where do I get the... Here we go. The data sheet for this microcontroller. Yeah, that's the thing. How do you do it? So it's a Cypress Fujitsu-ish microcontroller. And the thing about this is there's only so many pins on a 24-pin chip that you can toggle. It's not FCC accepted. This has no acceptance from any regulatory body in the world. It just doesn't. It's not Ofcom. It's not nobody's acceptance. You know, not FCC. It's nobody's accepted this radio. You know, it is a total black box. Yeah, it is a total black box radio. What they like to call an export radio here in the States. Yeah, it's... So I guess probing, I had 9, 10, 11, and 12 to probe left. That's got some kind of data going on right there. This one is another GPIO with trying to look at DC levels as well to see if DC levels are changing. That one changes that one changes the voltage level changes with mode. So is that the switch that's connected right up? Is that connected right up to the switch? Or yep. So that pin is just connected right to the bloody switch. Oh, maybe not. Okay. Yeah, it's connected to the switch through a pull-up. Or something like that. Looks like a pull-up. Or pull-down. Yeah, it's connected to the switch. So that one is getting the mode, so the radio knows what mode it's in. So that's what they're using that particular GPIO for. So that leaves us with the last two on that side. Which that one has a high on it. That doesn't change. Yeah. Alright, so that doesn't change. No idea what it's probably doing. Last one on this row. There's no jumper that is visible or obvious. I look for that. That's PTT right there. Okay, that's PTT. Yeah. That's a high when the radio transmits. Should probably be writing all this down, but so far I haven't come across anything that's sort of possibly it. This one has what is that? What is that? That's very, 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 very interesting, is what that is. These data pulses. Huh. Okay. This is like some kind of scanning pulse. This is the, I don't get what this is. What is it? Oh, it's got to be a DAC output. Does this thing have a DAC on it? I didn't think this had a DAC. Now that I think about it, that's like a DAC output. This didn't have a DAC in that, did it? Does it have a DAC? Come on. No, there's no DAC in here. It has OCD. Wait a minute. That's what that is. That's what it is. That's what that is. That's OCD. On-chip debug. That's the debug data pulses that are coming out of it. Serial data stream that is one wire, and it's usually a proprietary protocol, which basically means that my chances of deciphering this protocol are slim and none. So we'll just move on from the OCD to the next one, which just has a high DC level on it. Let's see, we key. Transmit, buttons, try all the buttons, switches. Like, I haven't found the channel 9 and 19 switch yet. Okay, that one is the... That's what that is. That's the AM/FM switching right there. That's the microcontroller responding to it. The other one is attached directly to the switch. This is where the micro actually responds. So, toggling circuits in the radio. How does the 9 and 19 switch do it? Can you elaborate? I'm willing to give it a go. Do you... Because I don't know how that would work. Because it's a toggle switch, so... You know, when I put this radio on channel 9, 26065, it's channel 9. Okay, so what you're saying is, oh, that's how it works. Oh, that's how it works. It's on band D now. So you have to put it on channel 9. You turn it on, and then you just change what you want. So PL. So I want PL, and then I just change it back, I guess. Okay, so what frequency are we on there? 26,960? 27,399,999, 2740 even? Okay, so that's the Polish band. So if I go to 9 again, turn off the radio, turn on the radio, and go to D, that's 27,405. And that's 2741? What? $2740 is on channel 40. So what's channel 39? Channel 39. So what in the hell was channel 1? $27,415? 425? Wait, is it going up in bands? So is this now 2785? Okay, so it's scrolling up through the bands now. 2786? Yeah. So where are we now? 28 megahertz somewhere. This is where we should be. 28,715. It's just no. It's just that's the top band right there. 28,715. It's just not going. It's not going down at all. It's not even going down. it's just maxed out. 28. The radio's like glitched or something. Let's do that again. D2, EU, CE, U, PL, D, E1, D2. What is E1? $27,405. $26,965. That looks like the CB band to me. 26,975. Yeah, that's the CB band. D2. I don't think I've caught a whiff of what D2 was. That's crazy the way it's changing channels though. 2700, that's channel 4. 015, channel 5. It goes from channel 4 to 15. What's up with that? And it's the, yeah. That's weird. E1, D2 is just something weird. EU, I get what EU is. CE, U, PL, D, E1. D is the one that was the CB band. 26965. We go down one. 26955. Okay, so we've gone down below 1 now. $26,515. $26,065. 2605. Oh boy, it's going down. $25,615. Okay. 25,605. It's going down. There really isn't a menu on this. Joey R. How is it going? That's 25,165. $25,14 on 39. Holy crap. $24,711. You gotta be shitting me. You have to be shitting me. And it has power too. Like, it still has 2.5 watts of output power. $24,265. Okay. $24,255. You've got to be kidding me. Yes, 24 megahertz. 23,881. You've got to be shitting me. 23 megahertz. There's no way this thing has to. Let's stop right here. Let me turn on the signal generator. Yes, it does. We can thank Scott here for documenting the findings. Well, you may be able to start with this, yes? I don't know. I haven't found the New Zealand band on it, but let me see if I can find the bottom, like the lowest frequency. I'm still going down in frequency, and we're still going down. It's just like, I want to see if this thing actually receives on 23,815. I don't believe it. I don't believe it. 3.815. I don't see any S meter. I don't think this thing's receiving a damn thing. It's transmitting, but I don't think it's receiving a damn thing. That's an RF gain. Let me get AM. Let's shed some light on the modulation. I don't hear anything out of this radio. Deaf as a post. Okay. So I've got 1 bar on the S meter that goes away when I'm in 23 megahertz, but I'm not getting any receive. Like, it's got nothing, you know. Let me turn this AQ crap off. Uh-oh, I may have lost my place. Uh-oh, I may have lost my place. Yeah, it's back on channel 1. Okay, we're still going down. I need to just hold the button for a while until we can get... I'm going to probably have to do a full workup. But we need to find the bottom. The top was somewhere in 28 megahertz, but the bottom is down below 23 megahertz. Down in the high 23 megahertz so far. The lowest I got it to is 23,815. And that's when I said, okay. You know, I don't know how many bands we went through, so let's see where we're at. 23.74. I actually got 23.79. Let's just go with that. 23.795. Oh, I turned it off again. Damn it. Turning the damn volume down. It's so easy to turn it off. Yeah, I got to go back through it again. But I have the generator on. And I didn't hear anything. So we're going to go down. Down, 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 down. Where are we at here? 25.145. Let's see if we hear anything there. 25.145. Yeah, see? It has receive. I gotta take the antenna loose so that, yeah. It's receiving. Yeah, it's receiving. Let's just keep going down. That's crazy. It's 25 megahertz, still receiving. All right, let's see where we're at here. 24.255. I hear something in the receive. It's receiving a signal from a signal generator. This just got a rubber ducky in it. Still receiving. Let's keep going down. Okay, where's this? 23.665. 23.665. Yep. It's definitely losing it, though. It's definitely losing it. It's not band specific that I can tell. It's just running to a range. You go, you know, down and like this is 23,500 even. We've hit bottom. Okay. Yes. I've hit bottom at 23.5000 megahertz. Let's see if it receives. It will not go any, yeah, 23.5. It will not go any lower. And it is not receiving anything that I can tell. Yeah. It is dead stick. Nothing. Let me crank the generator to max. Nothing. Let's see where this is. $23,500. Still. So you can keep going, but it just won't go. Yeah, but the 2950 might be able to receive where this one ain't. That's the thing. It's not receiving anything. 23,502. You know what it is? PLL's out of lock. Yeah, PLL's out of lock. So this 23.5 is just because the PLL, because it's probably just run all the way down to the bottom, but PLL is not locked because it's rolling. Let me find a point at which we regain control of the PLL. Okay, 23,805. So let's go down from here, halfway. 23,605. Okay. So let's see if we can get anything there. 23.605. It is receiving. So I'm on AM right now. 23,535, 52, 51. This should be 505. And it is. 23.505. So I think this is its bottom. Yeah. $23,505, I'm best guessing, is the bottom. Can we go down one more channel? 23.49. Huh. 23.495. It's not receiving. That's it. 23,505 is the absolute lowest, and that would be on channel 12. You can hear the PLL popping when you change channels. 23.505. Yeah, that's the lowest. 23,505 is the lowest. On this radio, it is on channel 12 of whatever band it is. So it could be that your mileage may vary on some radios, but it's still receiving. It's receiving very poorly. Let's find out. Because it'll tell you when it comes on. D, that negative D on the display. Now we got to find the top. And it's on AM, by the way. If that makes a difference, which it probably does. So let's see where we're at here. This is, I think, channel 20. When you turn it on or off, it always goes back to, yes, negative D. When you turn it off and back on, it always goes back to CB band. Wherever you were, if you were at 23 megahertz and you turn it off, turn it back on, it goes right back to CB. I think that's what Scott there's doing. I think he's making a map because he's putting up a web page, as I understand it. So he's probably jotting all this down on it. We need to go up now and find out where the top is on this particular band. Let's see. Let's see where this is. 27905. This is 28365. That's PLL unlock. Yeah, that's wandering. Let's go down a little bit. 28655. Let's see if it's actually receiving. Yeah, it's receiving. The receiver sensitivity is a lot better, so I don't have to disconnect the antenna. So, how high can I get it? Looks like 28705 on this radio. Seems like that's probably about last stable. Maybe a couple of more channels above. That's out of lock. Yeah, 28705 is last stable on this radio. That was on channel 35. Yes, channel 35. Yeah, this is a little tiny compact radio that it's just a fun thing to play with right now. But it's an undocumented CB, and very shortly you should be able to go to radiomods.co.nz and read all about it, I'm figuring. Oh, okay, so that was the negative D band. So the negative D band goes really far. So if I put this back in channel 9 and turn this on, E1 27405, 26965. Yes, I can definitely do that. Okay, starting from E1, D2, EU, CE, dash U, which I know is UK because we were on that one, PL, negative D, and we're back to E1. Now E1 was just CB, like FCC, as far as I can tell. 26965. Let's see where channel 4 is. 27005, and 3 is 26985. So it has a jump. So that was, what did I say it was? E1. So E1 is FCC, like an FCC band plan. And it went from 1 to 40. It didn't, go up above 40 or down below 1. So the next one will be D2. D2 goes from channel 4 which is 27005, 5, 2701, 6, 2702, yeah. So the Germans only have channel 4 through 15, is that right? I never looked at the German band plan. But yeah, Germany seems to be channel 4 through 15 only. FCC equivalent frequencies, what it from the looks like. EU is obviously going to be EU. 26965, 26975. I think EU has the doesn't have the jump on 23. No, it does. Somebody I thought it was one of them didn't have the jump on 23. It doesn't look like it. Yeah. So EU is FCC equivalent. And we have -U, which is UK, and we know what Sweden. Okay. -U is UK. What frequencies this thing's runs at? We know UK. Poland, or PL, channel 1. 2696 even. 2697 even. No. Europe. 2698 even. 26 or 27 megahertz even. Okay, I knew somebody didn't have the 23 skips. But all the EU bands look like they have the 23 skips. The Polish band is evens. You know, so 2696, 97, 98, 00, 27, 00, and so on and so forth. I'm guessing that it's going to do that all the way up to 40. 2740 even. So that was Poland. Now we're back to -D, which we've already covered. So that looks like the frequency ranges of the radio. That's actually an impressive little radio. The amount of channels, wowee. The amount of frequency range, and it still receives. It's deaf as a post, but it still receives. That's kind of cool. I mean, that's kind of cool. I mean, it's a little dinky. I think this is probably the smallest one that I've seen. You know? I mean, wow. This is the smallest little radio I've seen. Oh man, I'd have to get a Synad meter to hook it up to figure out where the lowest it could go and maintain 12 dB. I can tell you it ain't going to do that much through 26 megahertz. So I think we probably need to kill that notion right there. I mean, it ain't going to do it. I mean, I'm speculating that it's not going to do it because, well, how wide can you really get this and be effective? You know what I mean? It's just, I mean, how much 12 dB Synad are you really going to get on? How far is it going to go down? You know what I mean? It's like, yeah, I'd say it's probably like a 510 or a 520. It's a little dinky thing. Yeah, I just can't see the 12 dB Synad being much below 26 megahertz and much above 28. I just can't. Because I could tell by putting in the signal generator that it was rolling off. You know, because I was looking at its own S meter, and I could see its own S meter was rolling off. And yeah, when I was having to unhook the antenna connector, yeah, I know that the receiver sensitivity is going to be pretty poor. Much below 26 and much above 28. I just don't know how, that's the trick, that's the problem with widebanding these. It's like, you know, in order to wideband these, it just simply takes more electronics. But yeah, you do get a lot of bang for the buck. I don't know about its hello. Oh, it has really crappy modulation. It has some really crappy modulation. Let's find out. How much modulation? Hello. It struggles to make 60-70% modulation. So I'm sure one of these little tiny pots in here is probably maybe, you know, but I'm not going to just get in here and like turn things, you know what I mean? Like if I was a betting person, that one is probably FM deviation. Yeah, I don't know about that, fellas. There's really nothing to get to. The RF cage is inside of a cage. Yeah. You would, and the radio has decent output. You know, it has decent output. It has like 4 watts on FCC and like a couple of watts down at 23 megahertz. Hello. Yeah, I don't know. It's one of these things where it's like, yeah, you could probably figure out, you know, where its modulation limiters and things are, but, you know, it's kind of a why. it's a why. All right, where's my 980 SSB? I got a couple of those things around here somewhere. I just took it off of here. I need something to receive. All right, what did I do with it? I'm just looking at the thing. All right. What did I do with the 980 SSB? It's around here somewhere. One of them is around here somewhere. I got a few of them. Okay, what did I do with it? What did I do with all of them? I got that one. That one's taken apart. I can't receive on that one. Blast. I need to like keep one radio like assembled because I take them all to bits and now I want something to receive and oh, there it is. Well, I want to hear it in another radio. So, I got a 980 SSB here. One of these. And I'm just going to set it here next to this one, and that should be close enough. Boop. Should be close enough to go to. Ooh, this one's got the damn beep noise. I hate that beep on that. I haven't killed it on this one. Okay, so how come I'm not hearing it on this radio? Huh, that's curious. Oh, it doesn't have an antenna, it's just, you know. And you stuff something in the back so we can get an antenna. Because the other radio is attached to a dummy load. So, hello, 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 testing 1, 2, 3. Testing 1, 2, squealing. Feedback. It doesn't sound bad, but they are close together. Testing, testing 1, 2, 3. It's tinny, but yeah, I've never opened this radio. You know, this is just one that I've just never opened it before. The other one doesn't have the beep because I killed it, but this radio, you know, it was one that I just had setting up here, and I never really moved it off of one channel, so it still has the beep on. So, and I got another one that I got from that refurb seller, you know, not tested, not known if it's working guy that's still sitting over there that I never bothered to take out because, well, no, I did take it out. It worked, and I just stuffed it back in the box. So, yeah. Hello. It works. You could talk on it. People would hear you. You know, I think the microphone connector, the way that this is done, is probably the best part of this. Like, they actually molded a real relief into the cord and everything. I mean, you know, that's probably the best part of this. I think they did a pretty good job on the strain on this microphone. I think they must have paid attention. I mean, they paid attention to something. It looks like they actually did on this. Because this looks really good. I don't need any amps or any mods or any peaks or any power tunes or any of that stuff. I just need it to do what I use it for, which is primarily to receive. But other than that, no, I don't need it tweaked and amplified. I want to get a good look at this. Yeah, that's going to be the next thing. How does it look? I want to look at this microphone connector. It's like they did a pretty good job on it. I actually want to see a good job on a microphone connector for once. And that they did a good job on this. I mean, they really did. Someone, I think, was really thinking about this. Now I'm going to get in and I'm going to find bad soldering, and it's going to do it all the way. And the soldering is remarkably good. Wow, I'm impressed now. Somebody actually put together a proper microphone connector. Read relays. I don't do RF engineering. I can't see why it would be popular other than to just drive component costs up. And I would never read any write-up from an electronics distributor because they are always biased towards selling somebody parts. So never read write-ups on DigiKey because they're there to advert a particular product. They aren't there for the engineer to make good design choices. They're there for the engineer to be wooed to want to put that particular product device. Trust me, been in this business a long time. That's why it's there. It's there to woo guys like me. Now I'm going to go and put read relays and everything because of a read write-up. No, it doesn't work that way. Show me the data. Why? I don't want to read a testimonial, which is what a lot of those are. Now, some of it's good information. You just have to read it and take it with a grain of salt. But write-ups are there to sell components. That is the harsh reality of that. All right. Let's fire up this beast of an HP and have a peek at its output. The monitor is half covered, so I probably won't be able to see half of it anyway. Exactly. Not an electronic distributor's review. Because they're there to sell parts for manufacturers. That's why I just don't read them. A lot of times I just don't. People send them to me. DigiKey sends them to me a lot too. I don't read them. All right, let's see what we got coming out of this beast. Let's go to like channel 20 or something, 19, somewhere in the middle. 19's good. We've got one big tone at 27.18 megahertz, and we've got another tone at 54.1, 4.2-ish megahertz. I don't see anything in this radio that looks like a 54 megahertz trap. So there is a 54 megahertz tone coming out of this radio. I don't see anything that resembles a trap. There's an inductor directly on the coil of wire that goes to the antenna, but I think that's probably matching. That's probably some impedance stuff there. But there's no, unless it's in the can. But the can is obviously soldered shut, and all the shields are all soldered and everything. And then it's soldered to the back of the radio. Negative 62. And the noise floor is at negative 73. That's negative 62. So, it's close to, it's well, it's not really that close to the noise floor, actually. That's, you know, lots of orders of magnitude above it. I mean, it's a noticeable peak. That's obviously second. Let me go higher. Let me set my stop to something, you know, like 200 megahertz. Oh yeah, we got a pretty big third harmonic. Where's my marker? Marker. All right. 54. We have a third harmonic that's three times the size of the. That's at negative 49 dB, 81.6 megahertz. We've got a fourth at 108.6, so we're right there at the edge of the FM band. We've got a fifth at around 136 megahertz, and a sixth, and we start dying down. We're getting closer to the noise at 163, and we're almost at the noise at 190. No, it really isn't terrible. But they didn't build this to a specification of like stuff like no 54 megahertz. They didn't build this for that. Well, it is. But you know what? If I take that 980 SSB and throw it up here, I bet that's got some tones on it just like it. I've seen tones like that, just like that, on other radios. I'm not really surprised. I don't think anybody's ever really looked. They're lower, but it's a little dirty. It's because they don't give a damn, you know? They truly just don't give a crap. Especially on this, because it's just like, now I have to find the 980 SSB's microphone. Or a microphone to one of them. So that I can throw that one up here and try it out. Because I got no bloody idea where those microphones are. No, that's a Uniden, that's a D104. I don't know where the 980 SSB mics are. Probably in another box. I gotta clean up in here again. I didn't get to it this weekend. I just didn't get to it. Old Cobra crappy mics. A Crack Shack mic. No, I don't know where those microphones are. Oh, I see a few more microphones. Really got to clean up in here. A Bearcat mic. Oh yeah, there we go. There's one of them. Sensitivity. It works. It'll receive about 2 megahertz reliably. You know, 26 to 28. I wouldn't go much past that. Oh, you're asking hard questions now. Adjacent channel rejection? Oh man, you're asking me to do all kinds of elaborate stuff. I'm going to probably guarantee you that it's probably poor. I mean, look at the 10 megahertz trap filter first IF on it. I mean, I'm going to give it a poor based on what I see right there. It's just not made for, you know, find out how annoying that beep is. Alright, channel 20. Okay, SSB 980. Harmonics. Basically. No, I'd have to go and use a whole bunch of other equipment to do the testing of that. I just have to like create the setup. Alright, the SSB 980. And this is a stock one, okay? You know, so we got 4 watts output. It's a stock radio. It hasn't been tinkered. Alright, 54 megahertz, okay? We are at negative 60 dBm on the 54 megahertz for second, okay? Third harmonic, we're at negative 50 dBm at 81 megahertz. Okay, third harmonic. 108 megahertz, 58 dBm, negative 58. These are all negative, by the way. Fourth harmonic, 136 megahertz, negative 44 dBm. So it isn't much better than this SSB 980, really. This SSB 980 is putting out more power than this radio is. So of course it's going to have a higher output on some of these things. So, but yeah. And of course we go second, third, fourth, fifth, sixth, seventh harmonic before it goes off the edge of the span, which I have set to, you know, up 200 megahertz. So, yeah. All radios have them. I doubt it because the 980 microphone doesn't have buttons. Same connector, I think. What's the worst that'll happen? I'll blow up the microphone or blow up the radio. Same connector. Well, I got to give it power, but all right. Yeah, the other added bonus is they did make those pieces of equipment to be serviced, because you don't buy a stable lock 4040, have it break, and then chuck it in the bin. It doesn't work that way. They definitely made it to be serviced. Alright, so if I plug this in, that's going to be the first indication of an issue. It's actually changing channels. It's going... I would say that it's not working. Worth a try. Worth a try. Nope, the SSB 980 doesn't work. Same pin, same connector, but different, all different settings, or all different, that's right, a new feature, auto scan. Oh my. So yeah. All in all, a surprisingly interesting, you know, a really interesting little radio. But at the end of the day, if you needed a little cheap radio, I don't know. I mean, if you needed a little cheap radio to just go somewhere on AM and FM, you know, it might work for you. In all seriousness, it might just work for you. I can't completely knock it, you know. Other than the obvious design problems, like with the board connector, you know, the way they did that with the board, I don't know that I could really... It's a $40 radio that covers like 5, 6, 7 megahertz of range. You know? I can't... I'm actually trying to find, for the price, I'm trying to find something to knock it. And I can't, because it's... You know it's a cheap radio. I don't know. I'm having a hard time trying to knock it. And I don't think I can. I mean, I kind of got more out of it than I really expected. You know? I got more than I expected out of it. I wasn't expecting all this. You know? Yeah, I mean... I just got more than I expected out of it. I can't find any way to really... I mean, there's some obvious things with the build, but it's not bad built, even. You know? It actually... Other than that board-to-board, that's like the only problem I have with it. Like... I mean, it feels, the connectors feel kind of cheap. You know, the connectors, the knobs feel kind of cheap. It's clumsy to change bands and all that, but it's an AM/FM radio for $40 US. You know, what were you expecting? You know, I think I got more than I bargained for. So, yeah. I mean, you know, I mean, unless you guys can find some other, like, real faults. I mean, for $40, if you needed something quick, easy, cheap that had AM and FM, banana for scale, you want me to go into the kitchen and find the banana? How about a ruler? How about a Dave Jones ruler? It's the length of one Dave Jones ruler with knobs and connector. How's that? Does that work? I mean, one Dave Jones ruler. Oh, old Reddit joke. I don't mess around with Reddit. I know about it. I know of it, but yeah. Yeah. It's the length, knobs to connector, literally, of one Dave Jones ruler. So, you know, a Cobra 19 is like this thick, you know? So this is like a Cobra 19, but not as tall. Because a Cobra 19 is just a little bit higher than this. I'd say it's like 1.5 of these high. I mean, this thing is 35 inches high. And for you Imperial aficionados, about an inch and just under an inch and a half. Oh, I don't know why it would have gone quiet, but did you guys, any of you, see a problem? Nobody mentioned it, so. What's the web page? Let's take a peek at the web page. Obviously, it's radiomods.co.nz. Is it just in your area? Where would I get to it? So I can blurt out the URL. And why is radiomods.co.nz not loading for me? I've like never not had that not load. That's odd. Huh. That's very interesting. It's not loading for me. It's just like gonna time out. EV blog. A Hioki something thing that Dave Jones just put up. Alright, let's try radio mods again. Oh, there it goes. Beats me. I don't know what's going on with that. Why it didn't work. Alright. Radio mods. Go to the Radio Mods Facebook page. Where do I... Am I dense? Like... I guess CB radio. Yeah, am I going the right place? Or it's just / Luiton. It's in the CB area. Let's go back there. Let's go to the CB radio. Be sure to visit the forum. Go to the radio mods. Go to the members area. Go to the radio alignments. Go to the modifications pages, I'm guessing. Oh, I saw it. Luiton LT-298. Channel expansion. Multi-mode AM FM radio with stated possible frequency coverage 25.610 to 28.3. That is the specification that I believe that they stated, but this one in practice got more. But that's probably the safe range that you have up there. Bands are selected by turning the radio off, turning on the channel 9 switch, and then turning the radio on. Change channels to select bands, and the bands can be accessed. That's, yes. Restarting the radio, you got display spelled wrong. Yeah, I'm nitpicking things. We'll dispally. Will display the current band in use. Yes, that's right. And then you have the bands, E1, I2. I didn't have an I2, incidentally. I'm giving you crap, but I didn't have an I2 on this, which is interesting. That you have an I2 there, because I think you got that from the official. Well, let's go back through it and let's make sure I didn't miss it. Ding. Let's make sure I didn't miss it. This one I didn't have an I2 on it. No. All right. So channel 19 or channel 9. We turn it on. Okay. Did I break it already by putting it together? That would be funny. Oh. I got the power plugged into the two grounds together. All right, so D, I didn't get it quick. Oh, I have to put it in channel 9. Turn it on. D negative D, E1, D2, EU, CE, negative U, PL, negative D, E1, D2, yeah, EU, yeah, yeah, that doesn't seem to have, I don't have an E and an I on this one. There could be some other variant with it, but this particular one does not have an I2. Unless there's some other way to get it. It had everything but the but wait a minute now. D2 didn't have 80 channels. D2 D2 didn't have that. Let's go back to D2 and let me look at it. I don't think D2, my D2 didn't have all that kind of range on it. Unless it did and I'm just too dense. This is the one that did the crazy 4, 5, 6, 7, 8, 9. Okay, that's AM. This is FM. Okay. Yeah. Okay, so you're probably right. Yeah. So when I went to FM, I went to AM and it doesn't. That's interesting. If you flip it to FM, change it to like 3, and then go back to AM, it stays there and it won't actually move. Let's find out. I wonder if it's actually stuck on that channel on AM. And that's a way to get around, like to do AM on, even though you could just simply go to another band and get AM on those channels in Germany if you wanted. But it transmits. That's 27285. Okay. Lock it up. I typed all kinds of locked up. I can spell. Yeah, I can spell. All right. Sorry about that, fellas. The computer froze up, so while it was rebooting, I went and got a Seagram's. Woohoo! I think it gets too hot in this room, and I think that causes the computer heartburn, because it does get pretty warm in this room. Like if I take a temperature off of any surface in here, you know, such as the floor, that's the temperature in this room on the floor. So yeah, that's the floor temperature, and the camera's doing the hunt. All right, let's kill that camera hunting business. Yeah, it's almost 95 degrees in this room. Or, you know, for you, for everybody else, 35°C. Pretty damn warm. All right, let's kill the camera hunt problem. I was looking at whether this did 80 channels. And I glanced over and noticed that the computer wasn't moving anymore. So let's try this again. Channel 1, 27275. 27405. That's kind of an odd range. Um, 2699, 2689. I'm gonna guess, yeah, it's the, yeah, we've got the 80 channels on the D2 NFM. So I'm gonna go with that. Yes. The band lines up with what you've got. Let me reload that page. Okay, why doesn't my phone want to reload the page? Why did it take me here? I didn't want to go here. I do not accept any responsibility for any losses that may be, so on and so forth. So if you break your radio, it's your problem. Don't blame me. All right, so that was the Luiton. Okay. So, yeah, I think it's an interesting radio. So, I hope you guys found it interesting. Oh my. So, I don't know. Somebody said before, if I'm not mistaken, I don't know, where I just saw that. If I saw that in the comments here, or if I saw that in an email or something like that, but I want to bring this particular notion up. You don't have to buy, you don't want to buy one of these unless you want an AM FM radio that just has a shitload of channels just because you want it. I got it suggested to me because it was sent to me. Who sent this to me? One of you guys sent this to me in a text message or an email or something that says, check this out. It's a Seagram's ginger ale. I don't have any Jim Beam though. Jim Beam would go great with this right about now, but I don't have any Jim Beam. Yes, Jim Beam and ginger ale. I don't have any Jim Beam. And tomorrow is an early day, so I can't start the night right now. It's a little bit late to start the evening now. So anyways, yes, but ginger ale, Jim Beam and ginger ale. Yes, good stuff. No more Jim Beam, unfortunately. So I'm just drinking ginger ale. Anyway, what I was getting at is, you did send me it. That was you that sent it to me. One of you sent me a text message with it. Anyway, so someone said to me that we ought to probably get a bunch of people who are like, you know, willing to poke around and monkey around with these things or want to look at it and sort of mail it around. Dave Jones and a bunch of people did that. They mailed something around. I think it was, in fact, I was talking to Mike earlier. In fact, I think it was one of those Apollo boards that Fran Blanche had. And I think she sent it to Dave Jones, who then sent it to Mike from Mike's Electric Stuff, who then sent it, I think maybe back to Fran or something, so that they could all take a poke at it or something like that. Somebody suggested that to me one day. How come you guys don't do something like that? I don't know. Because if you're not careful, you're not careful about who you send it to, somebody will just keep it and they won't forward it on. I don't know. Not a completely outlandish suggestion, but you know, someone did suggest that to me. I think it was the 29 LX Max, actually. So why don't you just send that to somebody else and let them poke around with it? I only got one, and I'm trying to hack the display on it. Well, I already own the display. I'm just, you know, trying to figure out how to make it work. Anyway, memories on the channel board thingies. Let me find my 29 because I want to show this, because I've had a few you know, inquiries about this. What do I do with the 29? Here's the 29. Okay, 29 channels. Not channels, memories. So there's probably a better way to do this, but this is how I did it. For those who are so interested in memory channels, okay. So, you know, this is obviously one of these in a 29. And yes, it works. So, coverage on this is, you know, here to there. So, to -90 and 115. Although the top end is really sketchy. Bottom end is pretty good, and the bottom is actually good. The top is iffy. I think 100 or 28 megahertz is fairly reliable, and -90, which is 26, I believe 26065 is actually pretty reliable as well. But getting the display in this was really That decimal point is to signify scanning, because the scan is enabled on this. So if I close the squelch, it's going to scan. So that's what that particular decimal point's for, because the scanning is enabled. But if I key the microphone, it'll bump it out of scan. So, memories. All right, so I'm going to hold the channel selector in. We got brightness. Okay. That's the scan, so we turn that off. That's the Roger beeps. You know, the noises. That's our home channel. Didn't start off in the right place, but all right. Now that F1 that flashed up and these 3 dashes, this is favorite number 1. Okay? So from favorite number 1, it's not set. There is nothing set for favorite 1. So let's say I want to make that channel 1. That's favorite 2 now. So if I want to make that channel 4, I can convert that. Now this is number 3. Let's say I want to make that negative 10. This is number 4. I want to make that 10 or something like that. And 5 and so on and so forth. Let's say I want that one to be negative 30 and 6. Now I can leave them all dashes, which is nothingness. And I can just go through all of these menus and confirm nothing for all of them. Or I can simply plug a microphone into this and key the microphone, and it will bump me out. So I don't have to confirm all of those other ones. Now, you didn't see the menu option to go into the favorites because I actually haven't added it. It's literally the last thing that I need to add. Right now I've been toggling it in code just by setting it's a property in there, or a global variable. You know, it's pretty much a 1 or a 0, a Boolean. So there'll be a menu option. That's like the only thing I have not done. And that's because I don't want it to have an F and be confusing to people. And I'm trying to think about what I can display so that people don't know that the F that they're seeing is to turn on or off the favorites. Because if you turn on or off the favorites, like, it will only change channels. It is going to be the same program for the 148 board because it's the same board. It's the same board. I don't have any different boards for the radios. They are all the same. So it's the same code, the same program. You know, I don't believe in writing 4 different programs for 4 different boards, because that just gets ridiculous to try to handle. Especially if they have different microcontrollers, and then you start having, oh, well, I'll have to compile it for this one, and yeah, that's by far the easiest one to do. The long presses are actually quite hard because those are timers, and you have to get a timer into the seconds resolution. You need a 16-bit timer. The AT Mega 32, I believe, only has one 16-bit timer. So okay, yeah. I guess are you asking if it's going to be the same program that would be for the 148s? Then yes, that would be the same program. It sets up the same way. So if I go ahead and reset that, the only thing is this says CLR for clear. Okay? And yeah, and I'm going to probably change these menus around in the next refactor. It's just that I refactored the code and I copied a lot of the old menu stuff. And so, you know, I can set the brightness. The reason the brightness is the first choice is because if you have a green display in here and it's on the lowest brightness, it is so dim that you've got to really strain to see it. So you can say, okay, I don't see anything, and you can spin the selector at least to get the brightness up on the green display. So that's the PLL setting that everybody's familiar with. This radio is 8. This is, okay, and here's the thing, and I need to be very, very, very clear about this, because this is different from previous software versions. Previous software versions, you set the top and bottom channels. This, you set the top and bottom encodes. It's a little different. So if you don't know the top and bottom encodes, it's going to be a little painful to set one of these up. So this is the top encode for this radio. Now I can reduce that and limit the range by setting the encode. So this is the top encode. I'm going to leave it alone. This is the bottom encode. Okay? The reason the bottom is a 2 and it can't go any lower is because the 145-106 simply can't go to 1 or 0. There is no 1 or 0 on the 145-106. So it starts at 2. 2 is the lowest encode. And then you're just in. And that's it. So the setup might be a little bit more interesting because of the encode deal. But I can probably make a table up with the most common values. Like a 29 would be that 420 and 2. And that's because when you got the 455 kilohertz offset on this radio, so it encode goes goes up or down by 91, I believe. I'm pretty sure it's up by 91. So 420 plus the 91 would be 511, which would be why that is the largest encode that could be put into the radio. So, you know, because the PLL is going to top out at 511, it just doesn't go any higher. So, hence the, you know, 4, whatever it was, plus 91. So, yeah, the 420 plus, plus 91. I'm sure that a lot of people get that, why that is. Some people are probably going to have questions about, well, why? That's for like this radio. This radio has 5 kilohertz steps. So for every channel change, it increases by 2. You know, the encode value increases by 2 on this radio, which is why it is the way it is. And that's also what limits, I believe, mostly the range. It could go lower, but then again, I really thought about it and said, well, I could probably do a 145, 151 or some other PLL, but I really kind of questioned why. I think 26065 being the bottom is probably low enough for a Cobra 29. I don't think you need to go any lower than that. So, not to mention it's stable. So, you know, you just don't look a gift horse in the mouth. So that's really this is the version of this version is you can check the later versions by holding in the channel selector when you power it up, and you can see this is version 2. So if you have the other boards, you might hold it and it might say 1.01, 1.02, what have you, depending on however many release. The usable range on this 29 is 100, or here, to here. You can pretty much watch the S meter because it won't transmit when it goes out of lock. So, there, let me just... Okay, bottom frequency. I tweaked it so it's probably not... There we go. I did tweak it a little bit. I screwed around with it earlier. So right now it looks like that's locking erratically. 83. So 26135. I'm pretty sure it's 28 megahertz. Yeah, I screwed around with it earlier, so. Yeah, I screwed around with it earlier. So I know the range is a lot more than this. This is the only radio it's been done to. But on this radio, I typically get negative 90 to 100, which is 190 channels. So, yeah, 26065 to 28 megahertz is on this particular radio, the reliable range. Also have to keep in mind, I've only ever done this to one radio. This is the prototype for the version 2 firmware to boot. So, because it has support for PLLs and for radios that do 10 kilohertz steps. So, well, but you know what? I mean, in all seriousness, if you think I got to this, in 5 days, you're sorely mistaken. I think I perfected the actual software for the 3-digit displays over the course of about a month to a month and a half to perfect it. This is a totally refactored code base, although some stuff is copied out of it. For instance, this software doesn't use any tables at all. None. There are no tables. So, it works strictly off of encode. So it looks at the encode and it says, okay, I know that for this kind of PLL, for this kind of radio, the channel 1's encode is a specific code. And then it figures out the high and the low range from that. For 10 kilohertz steps radios, it's fairly easy because it's just go up by 1 and go down by 1. Yes, basically that's all this is doing, is just math. So the first code base was faster than this because it used tables. Tables are faster, but they take up more room. This code is 18 kilobytes compiled. The other code with the tables is about 27 kilobytes. So it's about 9K higher because of the tables. And I needed to get rid of the tables because of the memory implementation. Because we have to store all those encodes. 16 encodes, obviously they're 16-bit. They're 16-bit integers, so it's obviously 2 bytes use per memory. And it stores them in EEPROM, and then when it takes them out in EEPROM, yes. So it takes them out of EEPROM, it has to put them in RAM, because that's what happens. When it boots up, it copies the data out of EEPROM and puts it into RAM. That's compiler. This is compiler flag 01. So, basically optimize 1. As opposed to 00 or no optimization. So, no optimization, it still fits. It just is right around, I think with no optimization compiling, I think it's right around 25, 26K. So it will still fit in Flash unoptimized. When you're debugging this, it's a lot easier to debug the unoptimized code than it is to debug the optimized code, because the debugger can't set some breakpoints on some locations that have been optimized. For the simple reason that if it can optimize out some variables, it will. Like if you were to do char 1 or char A equals 1, you know, and then leave that there and don't do anything with it, it will completely optimize that out. That will just go away because it's not accessed or used by anything. It's set and initialized, but it's not used. So the compiler will just completely kill it. So if you set a breakpoint on that, you'll get the nasty triangle in Atmel Studio that says, I can't set a breakpoint on that. Well, of course you can't, because it got nuked by the compiler. It's an unused variable. You know, it was, you know, set but not used, or whatever the warning is. I think it's set but not used, or something like that. So now it's definitely some things are definitely difficult to implement in software. Memories were actually pretty hard. It really has a lot to do with the display. Right, and you're probably at that point where it's like you're going to write it, and then you're going to say, okay, now that I've written it, I need to go and take away all the spaghetti. So, and this happens with me all the time. You know, decades later, I'm still doing things like that. It's small enough of a project. Yeah, 1,600 lines. I want to say this is about 12,000 lines of code right now. It's pretty big. There's a lot of math. There's a lot of stuff in here, but this is also doing 2 data buses, SPI, I2C. So we got 2 data buses running. The I2C is running at in fast mode 400 kilohertz. SPI is running at 3 megahertz. So we got some really high-speed buses. So we're using hardware on both of those. You know, obviously the hardware, the UARTs, their hardware. The loop, the main loop, there's only like 5 things in it because it's pretty much, you know, abstracted to a point where it's like, check for encoder activity, okay, check for transmit, okay. You know, and it just runs through looking at GPIOs, like did you churn the channel selector, did you key the microphone, that sort of thing. You know, so that's all the stuff that's in the main loops for the most part. It's just looking for things to do. Other than that, it's not doing anything. It's just sitting there running around in a loop with a delay on the bottom of it. Well, my next project, I still have these sitting here, is these Chinese display drivers, which are really, really cheap, that I can get a lot of them really, really easily. And these are the, what are these things? These are the TM1639. Some of them have bent pins because, well, they chucked them in a bag and then chucked them in an envelope, and yeah. So some of them have a little bit bendy pins, but nothing too serious. Well, the timer that I've got checking the encoder checks the state of the A and B phase and the button. And that timer runs at about, I want to say 100 or 200 kilohertz of a rate. So it's checking that frequency, at that rate, it's checking the encoder. Yeah, I'm not doing anything like that. It's pretty much just the timer runs, the timer overflows, it checks the states of the pins, resets, runs until it overflows, check the states of the pins, that sort of thing. And it is a 8-bit timer. We don't need like super high resolution because we're not trying to run or monitor an electric motor. where we need precise counts. A user can tolerate a skipped count every so often and not notice it. You know, I've not noticed it, but I can look in code and I can see where it probably did miss because it might have been busy and it missed a step. It's possible, but yeah, one timer for the encoder. Then you have the scan. The scan uses a timer because what happens is when we're scanning, the scan is not turned on here. But you scan, the squelch opens, it stops the scan on whatever channel that opens squelch, so it stops. And then, as soon as the squelch closes again, we start a timer. And then we tick that timer down until it says, okay, and then it overflows, and then it says, okay, I can go back to scanning again. The reason that you can't use a delay, and this is a trap, so if you think about doing this, don't delay in your scan loop, because if you delay, let's say you are, and this is, I ran into this problem, these guys will tell you that this was a bug that they found out that I never stumbled across. In fact, there's still boards out there that have the older firmware with the bug in it that I don't think have been updated yet. If you delay, as in freeze, and don't do anything, you can't transmit, at least how this is done, because this is operating a relay. You can't transmit because we're waiting for this delay. But with a timer, the timer is an interrupt. So we can transmit and kill the squelch or kill the scan. So if the squelch opens, somebody talks, the radio stops, and the person using the radio wants to immediately transmit. As soon as that transmission is over, while that timer is running, because it's not freezing the microcontroller, because it's a timer, and it simply hasn't interrupted, they can transmit. So using a delay in the scan was just a horrible bad idea, because you couldn't you couldn't do anything because it's sitting there waiting for the 3 to 5 seconds. I think we set it to 4 seconds, 5 seconds or something from the time the squelch closes before we start scanning again. So there's like that gap where you can't turn anything or do anything because it's frozen up, because it's sitting there waiting for a delay. So that's how one of the other versions worked, and the earlier versions, and that's turned out to be a horribly bad idea that nobody noticed. You know, and there's probably, you know, a handful of radios that are still out there that have that particular bug in them, and the people who own them probably don't know it. They'll probably, you know, say something at some point to someone, and they'll say, yeah, I got a firmware update for that, but just send me the radio and we'll patch the firmware. So yeah, that's, you know, fortunately it's just USB, not this one, because I busted the board. I busted the USB jack on it and boogered this board up, which is why it's in a test radio. So I can't USB update it, but I can JTAG it, so it's not that big of a deal. It turned into a debug board for me. Yeah. Yeah, delays are good for small stuff. Yeah, the little delays, like when you have to delay to transmit packets of data. I don't think you can get around that. Not when you're bit banging. This isn't bit banged. This is hardware, so I pretty much, here's the packet. The hardware sends it, and then, okay, it tells me it's done. Okay, here's the next packet, and then it tells me when it's done. Here's the next packet, so on and so forth. So there's a queue for transmitting packets on the SPI and I2C data buses, And the SPI is not bidirectional. It's pretty much one way. It just gets fired to the controller. The I2C, I am reading the state from the expander. That is how I know if the PLL programming is successful, at least for the most part, is because I send it the 2 bytes, and then I read the 2 bytes back out. So I say, okay, here's your 2 bytes. It programs the registers. And then I say, okay, give me those 2 bytes, and then I read the 2 bytes. And the 2 bytes have to match what I just sent it. Because if they don't, then that tells me I have a pin state, because those registers are basically tied to these pins. And I have a pin state that's wrong. So if I have a pin state that's wrong, I either have a bad chip or I have a bad PLL. And it's smart enough to know that. So, you know, the only problem is the PLL would have to do something like drag the pin down in order for me to be able to detect it. So if it's just an open between from the ribbon from the board to the PLL, I wouldn't be able to detect that, because that's just the pin state is, you know, going to be a high or a low or whatever it is. But if I'm trying to pull it low and it's just staying high, then I know I have a problem with something somewhere. And what I can do then is, what it actually does is it forces the chip into the registers. It forces them into high impedance, and that's really to attempt to preserve itself from damage. Because I can set the I/O expander to high impedance. So okay, I don't get the wrong bits. High impedance to chip. And this happens in, you know, orders of it can happen as quickly as some microseconds, because the comms are pretty fast. So, you know, it's just something I put in there to try to prevent hardware damage, because otherwise it sits there and it's trying to pull up a power, you know, a rail, and it will probably burn up the internal FET drivers on the output of the register, and yeah. It's just an attempt to try to save the I/O expander from killing itself. So, you know, you can also set a lot of other things in these I/O expanders. You pull up resistors. Someone asked me about that while I'm thinking about it. How come there's no pull-up resistors on any of this? Well, that's because there's pull-up resistors internal as I/O expanders. I don't need external pull-ups. The other thing is a lot of these PLL chips have internal pull-ups already. So pulling up something with an internal that has an external pull-up, and you're pulling up really hard on something, you could start, you start, okay, so you got, you know, 20K pull-ups inside of a PLL chip, and then you go and you throw your other 10Ks in there. Well, now what have you got in there? 4 or 5Ks worth of pull-ups, so now I want to pull it down with something, and I'm drawing current now. And I'm dissipating that current through no, I don't want to dissipate the current through my I/O expander. It's not only wastes current, but it generates heat. It may handle it just fine, but there's no reason for that. So that's why these boards don't have pull-ups on them, because the PLLs have them pull-ups on them. But you'll see people who are, oh my God, we got to have pull-ups on everything. No, you really don't. Not when they have internals. Now, microcontroller pull-ups, I never use them. Well, if you're talking about the 145-170, which I think you are, you have to bit bang that, because it's got that weird initialization packet. You cannot send a 5-bit packet with the SPI controller. If you send it a bit or a byte of data, it will transmit all 8 bytes, which means 8 clocks. You know, that's why you have to bit bang at they have weird packet sizes too. So the 145-170, you have to bit bang it because of the initialization. There's just no other way to really do it. The hardware can't send 5 bits. It's going to send a full byte. and you can't tell it only send 5 bits. It just doesn't work that way. You're going to load the register and say fire it off, but you just loaded an 8-bit register, so there's going to be 8 clocks, and yeah, it wouldn't. Yeah, I can't think of a way to trick the 145 170 with a hardware SPI, because it's going to be 8 clocks, and the data sheet was very specific about it has to be like 5 clocks with 2 of the bits, because I did initially try it. Like, I did initially say send it hex value, whatever that was. That would have been what? That would have been like those last 2. So what would that would have been? That would have been 1, 2, 4. So that would have been what? 0x06 or something like that. And I think I would send that, and oh, yeah. Well, does it have an enable line on it? See, the problem with the data sheet said that specifically could, if it was floating at any point, you had to reinitialize. And the problem with something like this is that when you power this up, it is floating, because you haven't enabled any pull-ups unless you have a hardware pull-up like a resistor on the line. I don't put any resistors on SPI unless I have to, because I never know what peripheral I'm going to use on that bus, and having a hard pull up or pull down component on it, will cause issues. So someone sent me a webpage for the Luiton. But yeah, the 145 170 is that was an interesting and tricky beast to control initially because of that initialization packet. Somewhere around here I've got those other PLLs. I don't know what I did with them. I might have just tossed them to the side, and who knows. I got to clean up in here pretty big time. Put away like these varactor diodes and stuff like that. So what did I do with those PLL chips? The PLL chips that I'm referring to are the ones that were in the, what you call that radio? The black box radio. The one that leaves in the morning. The Magnum. And that radio, that's going to be one of my next ones to play with. But I don't know what I did with those PLL chips. I might have put them away, but I doubt that. While I'm thinking about it, I do need to put these in their ginormous bag. 145, 162. I'm going to play with that. But I kind of wonder why I would... I want to play with it just because I want to write a library for it. I got a ginormous bag for a bunch of 74AC 165Ds. You can't believe you understand this stuff? It's not that hard, actually. It's just ones and zeros. You know, it's actually not that hard. The problem that you start getting into tricky, like the 145, 170, is timings. That's when things get tricky, is getting the timings right. That's when you got to pay a lot of attention. You know, how quickly this pulse has to be, the rise and fall times of the pulse. You know, this clock signal has to be this. Yeah, that's when it gets interesting. You know, is when you get into those kind of issues. So, incidentally, the other thing that I got, I don't know if I mentioned it or showed this, because this is the only one that I need, is my test board. And I got to make a few more and send a few more around. But yeah, this one has a green display, but you can see the LEDs illuminated for you know, the binary encode value, and when you transmit, because this is running the Cobra, the Cobra 29 code right now. You see when I transmit, you see how it changes. So that's obviously 511 right there. So you can see that that's 9 bits, all ones right there. So that's 511. And that's the maximum value or encode for the 145-106. So you can see we're taking that and we're adding the 91 to it and so on and so forth. So, yeah, because you pretty much, you just take that, and I was testing the scan bits on this, but that's what the jumper was for. But, no, the Cobra 2000 has a board for it. It's this. One for the display, this just screws right in. So you take the other one out, screw it in, take the channel selector out, couple of standoffs, screw it in, done. But yeah, this is why I built this, because I got tired of looking at every one of the bloody pins when I was doing a new PLL. I was just like, I'm not doing this anymore. I'm going to build a board for this. So I'm going to reset this. And bright, you see what I mean by the brightness? Goes all the way down. And you have to pretty much crank it up for the green displays. So that's the top encode again. The bottom encode, and yeah, so that's the top channel. So if you look at that pattern there, that's going to be 1101000100, which is going to be something, you know, 400 and something. And then when you transmit, we add 91 to that, which gives us the 511. So that's an easy one to see, because you can see that all of the LEDs are illuminated, and you know, that's 9 bits, all ones for 511. So, you know, and for more, there's 3 more bits, but they're not used for this PLL. So that would be for anything that would be up to 12 bits. So, you know, that's your bigger PLL chips. So, yeah, in this case, the 2 ribbons just plug right into the board. You know, it's a handy, you know, test connector. And the idea behind something like this is, okay, I've got one of these in a radio. It's giving me trouble. You know, I just come over here and pull these connectors off. You know, they are a little bit short and tight, but you just pull these off, okay, and you just plug them in. So now I can confirm that, you know, turning the knob, looking at the display, I can confirm whether or not this is correct. So, okay, on that channel, I can squeeze the microphone and see that the binary sequence is changing, for example. So I know immediately looking at this, okay, I've got the correct code that I should expect for this channel. The knob works. You know, I can turn the knob, I can key the radio, I can do all that stuff. So I know that the problem is not here. So that's what this is for. You know, determining where the problem is, because you don't know if you got a problem with the radio or the board. It could be programming. It could be a bug, you know. So, you know, then you pretty much just plug that stuff back in and say, okay, well, I know it isn't this, but that doesn't mean that the cables are any good. So what you can then do is then remove these cables and plug them into this board, which is why I ultimately went with connectors on it, is so that, okay, not only can I test the board, but I can test the cables. So if I still have erratic, missing digits, erratic PLL programming, I can go and change it to another set of cables, you know, known good cables, and say, okay, I got a problem with my cables. You know, you'd be surprised of all the things you can get bitten by. So, you know, that was the idea behind all of this, is really just to, you know, work out the, you know, do I have cable problems? You know, what problems have I got with this thing? So, it would be, yeah, that would be definitely a useful tool, particularly when you're trying to diagnose encode values, something that clipped over the chip. That would be useful. In this case, we have a couple of things to test. We want to test the display, and the display, you know, in the radio, okay, I have missing digits. Is it the display's missing digits? Is it a cable? Do I have a busted trace? Did something happen to the display? Do I have a bad driver? Could have a bad driver. Plug in a known good display on a, you know, with set of cables into it. Confirm this is working. Okay, this is working. It's just a quick and easy way to diagnose a problem. You know, this is just something that I just, you know, sort of dreamed up, because I thought it'd be easier, for example, my debugging on this. Like, I had this for the Cobra 29 doing the code. This was invaluable at doing that, to getting the right encodes. I mean, this made it a lot faster, because otherwise I would be sitting there probing these damn pins. Okay, which one do I got there? What do I got there? This is a visual indication. I can just read this and say, okay, I know what I've got. So this was just instrumental in getting the code for the 29 done. I think I would still be plodding along with it, because this I could identify problems very quickly. Yeah, I mean, this was just very, very helpful to, you know, test jigs. And this is the thing, you start making stuff like this, and I end up with test jigs, because, well, it's kind of a necessary evil, you know, when there's, you know, probably within a few more months, there's going to be probably 50 of these things out there. And maybe a few months after that, there'll be 100. You know what I mean? So, yeah. So, you know, it's just useful to have tools. And it's useful to have tools that I can send to the guys who are doing these and say, here, guys, use this before you call me. Not that I don't like hearing from people, but it's a hell of a lot easier for me to say to, like, Mike, you confirmed the encode. Yes, I did confirm the encode. Okay, kind of thing. Yeah, I looked at it, because I'm going to have patterns to go with it, like what channels you should see what on what channel, and so on and so forth. You know, because I'm not expecting everybody to know how to sit here and add binary. I don't expect everybody to be able to do it. But having something where it's like, okay, D1 through D9 should all be lit on this channel in this mode. Well, I'm missing one digit. Okay, so we got a problem, kind of thing. You know, it's just, okay, where is it? Is it here? Is it the radio? It's probably here then. Okay, we got all 9, then it's probably the radio or the PLL chip. You know, on this one of these things. you know. So then it's probably a PLL chip or a ribbon cable going down to it. So, you know, there's a lot of failure points in this. Having a test jig obviously makes things easier. So that's why I made it. You know, I could have done some things differently on this. I did this really quickly. 10 kinds of people who knows who know and those who don't. Yeah. On this radio, I didn't have a noise problem. This has improved filtering versus the first variants. You may notice the big filter cap here. You know, right here. You probably noticed the big filter cap, all this filtering in here. I went on a kill the noise crusade because I don't like noise. To me, it's a problem. But keeping digital noise from getting into the radio is actually incredibly hard. I am going to come up with my own display drivers before long. I don't want to use something like this. Now, I don't use these display drivers on these. These are just ones that I got for grids because I think it was like 50 of them and it cost me like $10, $15 or something like that. The display driver in this is actually pretty expensive. It's made by Austrian Microsystems. Let's show you them. If I can find the bag with them in it. They are in here somewhere. Why is it that I have everything in here but the display drivers? Transistors, Zeners, USB connectors, more transistors. These are the drivers. Yeah, that was going to be my next incarnation of it. Basically what I wanted to do was put a push button on here so that you push the button and it displayed the value in like hex or something. Here we are. These are the Austrian Microsystems AS1108s, complete with desiccant and everything. And that's what's left of my tape of 25, and it looks like there's probably about 15 of them left there. So yeah. So this is the semiconductors that go in on the boards. I think I've showed you guys the passives. I'm pretty sure you guys have seen the passives. But here's the passives. This is all the passives for those boards right here. You know? There's all the passives right there. I have obviously tons and tons of more voltage regulators are in there, but yeah, I have tons of passives. Believe it or not, these reels don't cost a whole lot of money. I think these reels are probably maybe $15, and I could probably build. These are 10 nano caps, and there was 4,000 on this reel. I could probably build 4 of them, or 1,000 boards. 4 of them per board, 1,000 on the reel. I could build 4. I could build a whole bunch of boards. Let's put it that way. So yeah, that's what we've got here as far as reels are concerned. These are 22 puff capacitors made by Kemet. So yeah, the drivers are expensive. But I'll tell you what. I have, oh, it's here somewhere. I still have the original prototype on breadboard that I still reference, believe it or not. And I know this probably sounds batshit crazy, because it is. But here's the original reference, breadboarded, of this board right here. This is the original breadboarded prototype right here. So if you notice on this breadboard that you see two displays, it's because there are two displays. Oh, and my AVR ISP, the same thing that Dave Jones had, like, could not get to work. Which, yeah, and you can see there's my LEDs that I was reading out my my encode, and so anyway, this little guy down here, this is a display, multiplex display with a microcontroller down there, and this runs I2C data. That's the two data lines right here. And this display runs I2C data. And so the idea behind this is I want to use this microcontroller to drive sort of the next generation display, if you will. So that's what this is. This is one microcontroller for just driving a display. That's all this thing does, is driving. Oh, correct. However, why do you have noise from multiplexing? Okay, why? On this, where's the driver and where's the display? Well, the display is here. We got this data bus, you know, goes from all the digits over here to this connector, down the ribbon. It's an RF generator. It's the switching, right? So yes, you don't have multiplexing noise if you have a shift register per digit, correct. However, you don't have a noise problem if the driver is right up there with the display. There is no noise problem because it can't have an antenna. It doesn't have an antenna. The reason that this is noisy is because it's got all that ribbon to radiate it. But if the display driver was right up here behind the chip, you would never have any switching noise because you're right there. You're right on the chip. This board generated a shit megaton of switching noise because here's all the lines going over from the driver to the chip. This was noisy as all get out. I would hear this thing across the house in things. So, you know, but this one doesn't make any noise. This one runs slower and it runs quieter. And it's also the fact that I can take this microcontroller. I want to, exactly. There's no switching noise if it's like right there. The switching noise is caused by the distance between the display and its driver. That's where you're getting the noise from. It isn't because it's switching the line. It's just, you know, you can stiffen the power supply rail to prevent that, which is what all the caps are on here. This isn't correct. But if you have a display where the driver, instead of having this bigger connector, that's the problem. There isn't a driver that you can get that's small enough to fit on this board. I've not found one. The smallest thing that I have found that will fit on this board in the display and be driven, say, I2C, which will be slower and less prone to making noise because that's 400 roughly kilohertz. Is this microcontroller, and this is an AT-Tiny40. So this is a little Atmel AT-Tiny40. The thing cost $1 or less. I think they're about $1. The AT-Tiny40s. It has one I2C master or slave, and it has enough I/O on it to drive a 3-segment display. Now, I don't know about blinking it or doing any of that other neat stuff. I haven't tried that yet because this has built-in stuff for blinking and doing all that stuff. So, this is probably good enough for a display driver. It's also cheap enough, and the only thing you have to do, it's kind of a nuisance, you have to flash your board. If you find out what it is, and it's not a Maxim part, because I think Maxim makes one, but it's like notoriously expensive. Yeah, Maxim parts are expensive. I've got Max 7219s here. I don't use them because they just drive up my parts cost. Yeah, I won't use Maxim stuff. They drive the parts cost up too much. I use them. I have them. I use them in commercial products. But this, I won't use a Maxim on it. I'll have to add about $5 to the cost of this thing if I start using Maxim display drivers, because they're that much more expensive than these Austrian Microsystems ones. No, he has an iron that he can just grab the... Yeah, $6. You see, I'm not paying anywhere near $6 for these. I'm paying like $2 or $2.50. You know, that's just too expensive. I had to jack the price up in boards. Yeah, that's why I won't use them. They're too expensive. $6 versus like $3? Yeah, that's expensive for a semiconductor. I mean, that's hella expensive. That's a lot of parts cost. Double the cost. And the Maxims are actually harder to drive than the Austrian semiconductor ones. Like the code to drive the Max. This is like, seriously, to drive this, it's like 3 lines of code. Like literally. Yeah, it's 3 lines of code to drive this. It's kind of a no-brainer, you know what I mean? It's just like, well, it's 3 lines of code. The Mac stuff there's a lot more code involved. I have libraries for them. I don't use them because they're just, you know, I mean, I have some around here. They're probably in the giant bag of parts, actually, because I use them, but not very often. Yeah, so here is the giant bag of parts. And in one of these semiconductor bags is going to be probably, nope, LM1, these are, what the bloody hell are these? 74HT 595s. Nope, that definitely ain't it. I'll find it. Pretty sure they're Max somethings. No. RGB clear LEDs? What the hell did I get those for? RGB LEDs? I don't know, something. Oh, DC converters. Caps. I'm looking for the silver bags. Nope. Maybe I don't have them. Maybe I'm telling a fib here. Here we go. Here we go. Here's a couple of Max display drivers. They're DIP. These are... What are these? I think these are for Charlie plexing, though. A TM1639. You need one of these? Ouch, that hurt. I just rammed my bloody forehead right into the mount for the camera. TM1639, that's what these are. These are cheap. Like, these are like 50 cents a piece cheap, which is why I'm interested in them. These are really, really, really cheap. But I don't know how noisy they are, so I got to build a board with these in mind to try them out. But I thought I had some other Maxes in different form factors. No. Maybe not. Or they're up in the other... Yeah, they're probably somewhere else. What are these? SI 5351s. Oh, fancy that. 5351s. Yeah. I thought I had other Max drivers other than those. They're probably away somewhere. Or in the other ginormous parts bag box that doesn't have a home. These are parts that don't have homes. Like, I have no home for these parts. They don't have a bin or shelf or anything of the nature of that sort to be put anywhere. But what I mean by a home, like, they have no storage location. Because they're either oddball or something that's infrequently used. So, I have several bags of those. I don't think those counters would make a lot of noise. They're driven by these right here. Same shit. These things cost 50 cents, which is why they're using them. I mean, just cut to the chase. They're using these drivers because you went and got 40 of them. Yeah, because they're really cheap. And you know what? A guy I work with is working on going to translate for me the datasheet. Because it's in Chinese. And I need to just put it on and I need to try it. I mean, they're cheap. You know, you really can't go wrong with a cheap display driver, which is why I don't go with the Maxims. They're great. Don't get me wrong, the Maxims are great drivers. But for what I need it to do, they're just too expensive. So, yeah. Those frequency counter things, those ones that are driven by this, mind you, they're driving 8 digits with one of these. Just put that in perspective too. They are driving 8 digits with one of these. You can totally drive 8 digits with one. These are really good drivers. Yeah, run it at 8 volts. It'll run probably cool as a cucumber at 8 volts. 13 volts, too hot. But put 8 volts into it to feed the 5 volt regulator, it'll run cool. No problems. It's just, they weren't thinking about it, you know. They were like, if we run it at 13 volts, it's about, calculated, yeah, it's about 2C from running, you know, over spec of the voltage regulator. Oh, it's good enough. It's only 2C till you put it inside of a radio. So, that's how they think. It works at a bare minimum. But yeah, yeah, so this is 50 TM1639s just sent like this. I got these from AliExpress, I want to say. It's out there, but it's in Chinese. And this one, if I write a driver for it, I'll probably put the driver up as an open source thing because nobody has code for these. Nobody has code for them, except the Chinese, because they use them in everything. I've seen these things used in bloody radios. Case in point. Yeah, the data sheet's in Chinese. There is no English translation for it. There's enough in there that you can barely make out some rudimentary specifications of it. But otherwise, nope, you can't read it. Arduino, I can't use Arduino libraries. I write all of my code for commercial purposes, therefore I don't touch any GPL and stuff. I was an open source developer for many years, but unfortunately in the commercial world, the GPL is toxic. So I can't touch it. I can't look at it. I can't think anything about GPL. Nothing. I don't touch GPL code. If it's GPL code, I won't look at it. I can't. I legally cannot look at the code. If I derive anything from that code, I could be liable. I mean, I do this for, for a living. I can't look at other people's open source code. I just don't do it. I don't search for it. I don't fool with it. I don't touch it. If it's open source, I can't look at it. If it's people's closed source stuff, I'm perfectly okay. Because then there's, if you send it to me, well, I don't have a problem with running Linux. I used to do it for many years because I used to write, case in point, like this stuff, 10 years ago I was writing code for micros on Linux system. I used it for many years. But I've since migrated to Windows out of necessity because I've had to over the years. It's pretty much, I don't have a choice. All the software that I use runs in Windows. All the software that I need runs in Windows. So I have to use Windows. But it's a have to. So, but yeah, if I was to find, like, somebody was to send me this Arduino, the instant that I see most things that have a file extension of INO and people have sent them to me, I immediately delete the email. Yeah, I mean, and that's the thing. Yes, we do have Exchange, obviously hosted Exchange, so we have, all of our internal systems are integrated with Office 365, and yeah. This wonderful thing on my phone that's called Outlook. So, yeah. No, it can't be, but I haven't even looked at it, in all honesty. I haven't looked at it. The other thing that I was going to look at, just so that I can get an idea of what I'm thinking about or looking at, is I could simply attach my logic probe to this one. I don't mind Outlook. I don't really have problems with it. It just works for me. There's some things about it that are clumsy, yeah, but Outlook just works. Anyway, what I was thinking about is this uses the TM1639. And if I get stuck, I'll just come over here and I'll bodge a couple of wires onto this thing and I'll fire this thing up and see what it's sending it, for like an initialization or something. And I only do that because I can't read the Chinese on the data sheet, but I got a bloke at work that's trying to translate it for me. He doesn't understand some of the things that are written because of they're apparently different dialects of Chinese. So he's like, there's some things that are written there that don't quite make sense. But he's working on it for me. So I only need it to figure out what to send it. Once I figure out what to send this, I don't need the data sheet anymore. I'll just write a library for it. I will probably open source the bloody thing because there's a few things that I really do kind of sort of want to open source, just because I thought about open sourcing a lot of my KiCad libraries, or KiCad, or however you want to pronounce it. A lot of my KiCad libraries I'll probably upload to GitHub. Something come up last week. I want to say it was not last week, week before, about a Chinese designed thingamabobber. Who sent me that? Anyway, this display look familiar to anybody who sent me that eBay listing? Look familiar? That's because I had a project that used this display. Okay, you did. I had a project that used this display, and it was using the SI 5351. I never showed it. Sam, I am. Anyway, I never showed it. I never did a video on it. But I uploaded the code to GitHub. And I didn't finish it. The display stuff was there. The icons were there. The fonts were there. The basic idea was there. It was a DDS VFO. All the code was up on GitHub. The Chinese copied that code and they're now selling that particular thing. Finished. I didn't finish it. I gave up on it because of birdies. And they're selling it on eBay with my code. I shit you not. But I open sourced it. So I really can't bitch. I really can't bitch. I open sourced the code and they're selling the stupid thing on eBay. I got it. I was like, you gotta be shitting me. I mean, you gotta be shitting me. And they're selling it on eBay. The board layout is almost identical. I mean, they changed some things, but yeah, it was my design. I had the board files for Eagle, because I did that one in Eagle, if I'm not mistaken. And I put all that stuff up on GitHub, and I said, here, it's a VFO for a radio. Have at it. Because that was what was originally going to happen to this one, too. I was going to put this one on GitHub, but people talked me out of it. But that went on GitHub, and lo and behold, it's on eBay. Yeah, but I never finished it. But I started getting these emails about, I don't know, 3 or 4 months after I had uploaded it and asking me if I was going to finish it. And I said, no, I'm not going to finish it. Have at it. If you want to finish it, you're more than welcome to. Just send me some pull requests and I will, take it. And I noticed that it had like a whole bunch of forks. And I said, okay. And they were all Chinese. When I actually went back and looked at it, and I said, oh, the Chinese forked it. The Chinese forked it, and the Chinese just, yeah. So, yeah, they copied it. But I open sourced it. I can't complain. I can't complain. I did that to myself. So, because it was the precursor to the Cobra 2000 project, in fact. I mean, that's what it was. It was the beginnings of the Cobra 2000 thing, where I was using the SI 5351s. Anyway, guys, it's midnight, and I need to call it a night. I probably, I get a hair bug up my ass. I'll put one of these on board and throw it on a breadboard and start poking to see what I can draw up. Emails at midnight. I'm not answering you. Go away. So anyways, it's been fun. This code, once I put in the option to turn on the favorites, which will probably take me 10 minutes in all seriousness, I need to think about it a little bit more. Like about the F thing, because there's only one way to do an F. Maybe I put FA or something like that to distinguish them, but because I can draw an A. I'll do FA and a 0 or a 1 to turn on the favorites mode. And, this way you can scroll through the channels and it will only do the favorites. So, when I get that done, I'll send it to a few guys who want to test. You have to let me know if you want it for test with a board. Flash it to a board. Tell me all the nasty, gory, nasty, obnoxious bugs that it will have, because I'm pretty sure there are a lot. And then we'll do a bug killing. We'll get a can of Raid and we'll spray it and we'll get rid of them. So it's been fun, guys. Sorry about the hiccup. If I leave abruptly, it's the computer crashing. I don't just like abruptly boop, or my internet died. Something happened. But hex me. Yes, I will send you a hex. I'll put the option in the menu and I will send you a hex. I also have to send you some boards too. Tomorrow. The post wasn't running today. The Americans had a holiday for presidents, whom Donald Trump isn't worthy. Anyway, you guys have a good night. Cheers. Catch you, later, whenever. Maybe I get something interesting in the post tomorrow. Maybe I don't. Maybe I take a break, another break. But coding will happen. Yes. You guys have a good night. Gump Day. That's right. Gump Day. President Gump. He's either President Gump or he's Adam Susan, the High Chancellor. Anyway, good night, guys. Cheers.